Okay, hello everyone. Now in this part, since we just covered the internal force vector and we did the analysis on that, we're going to now be looking at different forces involved. So just quick review, we found out that the joint of interest is the knee. The motion here is happening in the sagittal plane with a medial lateral axis of rotation. So now we want to look at the external forces involved in the motion that's happening here. So we looked before at the internal force being the hamstrings trying to bend the knee flexors. So now we want to look at what is the external force that is also involved in this motion. So we can see here pretty easily that the external force involved here is the practitioner's hand, the person here that has their hand on the person laying down on the back of their leg. So now we want to look at the point of application for the external force. So remember that the point of application was just the location where we could pinpoint that the force is being applied. So for the internal forces, for muscles, we found out that that was the insertion point of the muscle. So now we just want to look at where the person's hand, the practitioner's hand, is in contact with the client's body. And here we can just say that it's where the hand meets the foot or the leg. If we want to be more specific, it's the distal part and the posterior surface of the tibia, just where the hand is meeting the ankle, basically. So now, if we were to represent this as a vector, we know that the vector has to go through the point of application. So we can do the same thing we did for the internal vector. And we would draw it going in this direction. So now, the next step is to find the moment arm. Remember that this is just the perpendicular distance from the line of force. The line of force just being represented by this vector here with the arrowhead. The distance between that line of force and the axis of rotation that's going through the joint of interest. So we know that has to be perpendicular, so we're going to draw a straight line. And we represent it with this 90-degree angle showing that it is perpendicular. So now we have to analyze the vector. We want to know where it's located and the direction that it's pulling or pushing in. So first, if we're looking at the location, remember that our location of our vector is in relation to the joint of interest. So remember that this person is prone, laying down, and we use our directional terms in relation to the person's body, not our view. So we know that the person's feet are down here, so that's going to be their more inferior portion, and their head is going to be here at the right side, more superior. So our location, we know that it has to be the way that the moment arm travels to get to the vector. So we know that the moment arm has to travel posteriorly, and it has to go inferior. Because if we start at the knee, we go down to the feet, that is posterior. Sorry, that's inferior. So we know we have to go inferior, and we also have to go a bit posterior. Now, looking at the direction, it's just which way is the arrow pointing. Again, remember that the person is prone, so that their ventral side, their anterior surface, is going to be laying flat on the table, and we know that arrow is pointing anteriorly, and it's also pointing downwards towards the feet. It's not pointing up towards the head. So the direction would be anterior and inferior. Since we know that it's at a diagonal, if it's at a diagonal, we know that we have to use at least two words to describe it. Here, interior and inferior. So we knew that for the internal force, that the knee flexors were trying to create a knee flexion torque. So what is the practitioner trying to do? Well, the practitioner is trying to stop that from happening, or at least trying to do the opposite of knee flexion. So we know since the vector is located inferior and posterior, and it's pushing or pulling in an anterior and inferior direction, then it has to create a knee extension torque, basically trying to do the opposite of what the client is trying to do. So now if we put it all together with the internal force vector, this is what it would all look like together, the entire free body diagram, showing the internal force vector, the moment arm for the internal force, external force vector, and the moment arm for the external force. So now we can go further with this. Now, if we were to ask which one of these forces is winning, we can tell what kind of contraction is happening and what motion is happening. So if we want to look at a concentric contraction, we know that this is when the muscle fibers are shortening. So if the muscle fibers of the knee flexors are shortening, we know that the client, or the internal force, has to be winning because they're creating the knee flexion. So in a concentric contraction, the internal force is going to be winning or outweighing the external force. Now, during an eccentric contraction, we know that this is when the muscle fibers are lengthening. So that's just the opposite of the concentric contraction. So for an eccentric contraction, that means that the practitioner, or the external force, is going to be winning and outweighing the internal force. Now, if we were to look at an isometric contraction, we know that this is just a contraction when there is no change in the length. So neither the internal or the external force is winning. However, they're going to be equal. As they're both exerting the same amount of force, they kind of equal each other or balance each other out so that there is no movement. So here we can say that the external force is equal to the internal force.